Yes guys, now question number 12, property number 12 here. Now I'm doing property number 12 which was left over. Okay, up to 11th we have completed. Now let me take the 12th one. What does it say? Let me write here. If it says if A is equal to Aij is a square matrix, be a square matrix, be a square matrix, be a square matrix of order n. Here order n. Okay, and let Cij is the cofactor of Aij in A for every element for I and j is equal to 1, 2, 3, etc. up to n. Here I and j, I'll just clarify that what it means. This is Cij means C11 for example is the cofactor of A11, C12 is the cofactor of A12, etc. So cofactor of every element of the given matrix we are given here. The Cij represent the cofactor of every element Aij. This is the general form here. So where I and j denotes 1, 2, 3 up to n. Okay, up to n. And if C is the matrix of cofactors, sorry, this is Cij. Let me take Cij is the matrix of cofactors. It is the matrix of cofactors. It is the matrix of cofactors. The matrix of cofactors of elements in A. All right. Then we have to prove that determinant of this matrix of cofactors is equal to A, determinant of A over n minus 1. Suppose this matrix is a square matrix, both are square matrix of the same order. For example, if C is a square matrix of order 3, A is also a square matrix of 3. But when we find a determinant of matrix of cofactors C, then it comes out to be, okay, value of determinant of A at n minus 1 times, means if it is of order 3, then it will come out, power will come out as 2. So that is we have to prove. Now let me prove this. This is proof here or solution. Let me solve this question, very important question. This is now in this, let me use some previous properties. What are those previous properties? If I find A transpose, you know that determinant of A transpose equal to the determinant of A itself from third property. Determinant of A is equal to determinant of A transpose from property number 3. This I will use. The second property is that if I multiply in every element, that A is Aij, be a square matrix of order n, that the sum of the product of elements of any row with the cofactor of the corresponding elements of the same of the some other row column is 0. Means when any element is multiplied by cofactor of another element of the corresponding element of other row. Okay, for example, if I take A11 and if I multiply this by A21 or the C21, cofactor of the first element of the second row. Okay, and I am considering the first element of first row A11 into, if I take C21, then it is 0. Why? Because this is property number second here. But if I multiply any element by the corresponding elements cofactor by corresponding element of another row, the cofactor of that if I multiply. This is the second property I have proved. With this property I have to use here. Let me take. So because this we have proved number of times, okay, for the students' request. So let me just take by that first by that method, then I'll take numerical question. Okay. Let me take. Let A, the matrix is A11, A12, A13, A21, A22, A23, A31, A32, sorry, A32 and A33. This is your matrix of order 3. A matrix of order 3. This is square matrix of order 3. Because determinant is calculated off the square matrix is 1. Now C will be then C is the matrix of cofactors. Matrix of cofactors of A, of matrix A. Matrix of cofactors of A. Cofactors of every element of A. Of elements of A, let me take. Of elements of A. What is this? Let me take this. Is C11, C12, C13. This is C21, C22, C23, C31, C32, C33. This is matrix of cofactors. Okay, and these cofactors of C11 is the cofactor of A1, C12 is cofactor of A1, etc. Every element's cofactor is this. So this is the matrix of cofactors. C is the matrix of cofactors of every element of A. That is the point. Now if I find A transpose, then A transpose, let me write AT or A dash A transpose. This will be equal to the matrix transpose of A will be written as first row has become first column. This is A11, A12, A13. This is A21, A22, A23, and A31, A32, A33. Alright, this is transpose of matrix. Now if I multiply these two, C and AT, let me multiply them. Therefore, multiplication of CA3, and what is determinant of this? This determinant will be, if I find determinant of A here, let me find what determinant of A here. This is nothing but A11 into A22 minus A33, this value, okay, and then minus A12, determinant of A12 into, this is A21 into A33 minus sign, this is A31 into A23, A31 into A23 plus now A13 into, this is A13 here, and that means this multiplication, this is A21 A32 minus sign, this is A22 into A31. So this is the value of determinant A. A determinant. This is value of determinant A. Let me write here. So determinant, I'm sorry, this is value of determinant here, or let me write here determinant A is equal to this value. This is determinant A. Now let me write here. What is the multiplication of these two? C into A transpose. Let me write here. C into A transpose, let me find out. Now C into A transpose multiplication. Let me write them. C is here, this C11, C12, C13, C21, C22, C23, C31, C32, C33 into A transpose is this A11, A12, A13, A21, A22, A23, A31, A32, A33. Now these two matrices are multiplied that we gave. So what it will be? This is the same thing here. Okay, now let me multiply these two. The multiplication of these two. If I multiply them, so it will be, let me write it in detail. This is equal to, now first row multiplied to first column. So first will be, this is A11 into C11, corresponding elements corresponding this, plus C12 into A12, plus this is C13 into A13. This is the first element. Okay. Now C11, C12, this is the cofactors. C11, C12. Now this cofactor. Now we know that the first row, if I find out the coefficient of them, C11 multiplied this is nothing but determinant value of A. We know that in form of cofactors. In terms of cofactors, this is the value of determinant A. So you will just calculate. Now if I multiply by first row, second column, first column, third column, let me multiply by first row to second column. It will give us here C11, this is CA21, C11, A21, or first let me write A21, no problem. Then this is A22 plus A22 into C12, then A23 plus A23 into C13, 0. So this is different cofactor, or A21 is the element of the second row, first element of the second row, and this C11 is the of first row, corresponding cofactor of the element of first row. This is 0. This is also 0, different one. C22 into C12, different. This is from second property here. Second property says, and when we multiply any element of any row by the corresponding cofactor of corresponding element of another row, then it is 0. This is 0 here, this is 0, this is 0. Alright. Third point. Now if we multiply by first row to third column, so it will be A31 into C11. This is also 0, different cofactor. A11 of, different row. This is our first row. Cofactor is of first row, and element is of third row. 31, first element of third row is 0, plus sign. Now this is A32 into C1, this is also 0. Now plus sign, A33 into C13, this is also 0. What we see, 0, 0, 0 plus 0 plus 0. And this is the value of determinant in terms of cofactors into element multiplication. That's right. Now second row, first column, what it will be? It is again A11 into C21, 0, plus this will be 0 here because different elements and different cofactors. C22, C12, 0, plus this is CA13 into C23, 0. But what about this? Second row, second column. This is A21 into C21, same. Okay, this is value of the second. Yeah, this can be. We are now opening the value of the determinant with respect to the second row, because A21 is the element of the second row. Cofactor of that row, that element is C21. Alright. Then plus sign A22 into C22. Got the point? Plus A23, C23. This is also the same answer of value of determinant A. This is into C23. A23, C23. Same element, cofactor of the same element. So this is giving us, we are opening this determinant with respect to the second row, element A21, A22, A23. Alright, this is the value of determinant A. Got the point? Then second row, third column. This is A31 into C21, 0. Plus this is A32 into C22, 0. This is 0 because this is different sign. Now this is A33 into C23. This is also different. Cofactor is different, element is different. I mean, corresponding element is there, but of different row. C23 is of second row, third element of second row, and this is third element of third row, 0. This is 0 here. Alright, then third row and first column. This is what? This is A11 into C31. This is also 0. A12 into C32 plus A13 into C33. When different element, different cofactor, 0. This is from property number 2. Okay, that is what we have taken. Now, third row, second column. So this is A21 into C31 plus sign A22 into C32 plus A23 into C33. This is also 0, complete 0. Now the third one, let me take. Third row, third column. This is the same, I think, A31. Yeah, A31 into C31, good, plus A32 into C32 into C32. This is A. Okay, plus sign A33 into C33. Same element, same cofactor of the same, cofactor of the same element. This is also determinant value. What is this? Let me write here. This is nothing but, this is value, determinant value of A, first one. This is value of determinant A. This is 0. This is also 0. Total 0. This is 0. Because different cofactor, different element, 0. This is same, 21, C21, A22, C22, A23, C23. So this is value of determinant here. Value of determinant. This is 0. For different element, different cofactors. Again, this is 0. This is 0 here. Now this value is 0. Now this is different. C21, A21, C31, 0. A22, C32, 0. Different element, different cofactor, 0. Same element, same cofactor. This means determinant value. This is also value of determinant A. Value of determinant A. This is, we are opening with respect to third row. So if we open third row with respect to third row into cofactors, multiplication of cofactors, that will give us the value of the determinant. This is this matrix. So matrix, this is diagonal matrix here. Okay. So we know that what is the probability of this whole. So now we see here, if we find determinant of this diagonal matrix, what is determinant of C8 transpose? Determinant of this is equal to determinant of this whole value. This is nothing but determinant of this matrix, of diagonal matrix, is we multiply them diagonal elements. This is determinant A whole cube. What the point? Because this is time determinant value A into A. All the three determinant values are multiplied together, so this is power cube. Because we have just proved here diagonal elements, which one? This one, 10th property. If A equal to Aij is a diagonal matrix of order n, then determinant value of A is equal to A11 into A22 into A2, A33. Means diagonal elements are multiplied. Here also diagonal elements will be multiplied. This is determinant value of A whole. Now what about this? If I just open this, C into A transpose, if we find determinant of two matrices, then that is equal to determinant value of C into determinant value of A transpose. We can change this into this form. So AB, determinant of AB is equal to property, this is from property number this 11th, from property 11. Property 11. 11th property is determinant of AB multiplication equal to determinant of A into determinant of B. Similarly, determinant of CA transpose equal to determinant of C into determinant of A. This is in the left hand side. So from property 11 here, and this was from property. Previous property was second and third that we have used previously from properties. Let me write here from properties second, third, 3. 10 is also being used. Okay, we just use 10th here. This multiplied from property number 10. Also we have used from property 10. 10, second, third, 10, 11. This is property 11. So determinant of C into determinant of A transpose is equal to this determinant of A whole cube. Right condition. But A transpose, determinant of A transpose equal to the determinant of A. This is determinant of C into determinant of A. A transpose determinant is, this is property number 3rd from property number 3. For A transpose, we know this determinant of A transpose equal to determinant of A from property number 3. From property 3. From 3rd property. Okay, so this is C into A transpose is determinant of A. This is equal to determinant A whole cube. This means determinant A 1 cancelled out. This implies that determinant of cofactors is equal to determinant of A whole square only. This is 3 minus 1. We have proved here n minus 1. The power has come out as n minus 1. Therefore, this cofactor was, matrix of cofactors or matrix itself A was of order 3, square matrix of order 3, but the value of determinant of cofactors determinant is equal to determinant of matrix of cofactors or is equal to A square is coming, determinant of A whole square. That means n minus 3 minus 1. That means n minus 1. It has been proved. Once it is proved, this is what we have to prove here. Okay, so therefore, determinant of C is equal to determinant of A whole power n minus 1. This is if C is or matrix A is of order n, then it is n minus 1 power. Determinant of C is equal to determinant of A whole power n minus 1. Here it was of order 3. We have proved that this is coming as a whole square. Power 2 is coming. Determinant of C is equal to determinant of A whole square. This is what. If this has been proved, hence proved. The property has been proved here. We have proved by algebraic method we have taken. Okay, considering some unknown numbers and then we have proved. So this is the property number 12. If numerical question can also be taken, doesn't matter. Okay, now let me take the numerical question to prove this. Okay, so that will give us something. Let me take one numerical question here. If A is of order 2, let me take, if A is equal to a matrix of order 2, let me take 2, 3, 4, 5, no problem. What is the answer here? The determinant value of A, let me write, determinant value of A is equal to factorial 10 minus 12. That means minus 2B. What we do? We multiply the diagonal elements first. Factorial 10 minus 12. This is the value of determinant A. The square matrix we have taken. Now the value of cofactors, matrix of cofactors, let me find out. What is matrix of cofactors? Let C is the matrix of cofactors is A11, or let me take C11. It is C11, C12, C21, and C22. What are the elements here? C11, if I find out, this is C11. What is cofactor of 2? 5. It's 5 here. Cofactor of 3, if I find out, because this is lying in the first row, second column. So this is 1 plus 2, 3, negative. Negative value is minus 4. It is minus 4 here, negative. Then of this is 2, 1. Second row, first column, this is also negative value. What about this? This is 3 here, minus 3. Cofactor of 4 is minus sign into 3. That is the value here. Sorry, this is minus 3 here. Cofactor of 5 is simply this, because this is 2, 2, even number. So this is minus 1 is 4, plus 2 plus 4 is positive. So this is 2, positive value. This is cofactors, matrix of cofactors. Now if I find determinant of C, what is determinant of C here? Let me multiply this with 5 to 10. Minus triple minus sign is there. It is 4 to 12, but triple minus sign. It is minus 2 here. Again it has come as minus 2. Minus 2 power 1 is minus 2 only. Okay, so this can be written as determinant A only. So the power is 1 only, because this is minus 2 power. We have 2 here, because this is minus 2 power 1. If we take this negative value, same. So determinant C is equal to determinant A in this case, because the order of determinant C or matrix C is 2, and this is of order 2 minus 1 means 1 power, that is same value has come. Proved. This is numerical value we can take. Okay, first we find matrix of cofactors. There's C, we have calculated matrix of cofactors. And after that we find determinant of C, and what is determinant of A, then we compare. This is A here, 1 power, that means minus 2 only. Power 1, minus 2, only minus 2. Determinant C and determinant A, in this case, are coming same value. But this is of order 2, this is of order 1 here, power is 1, minus 2, same value. Hence it is. This is numerical value we have taken. What the point? So this is what question number, property number 12 we have put here. And other numerical questions can also be taken to prove this. So this is what properties, all 12 properties are put here. Okay, so these are very helpful in the case of solving the determinant questions of determinants. Okay, that are discussed in the next classes here. But before taking questions, I'll take some applications of maybe applications. Let me think of this. Applications of determinants in different fields. For example, how to find inverse of a matrix. For finding the inverse of a matrix, there is requirement of this. Area of triangles. Okay, solution of simultaneous equations. Very helpful. Determinants are there. Determinants is helpful in case of solving simultaneous linear equations by Kksharma's rule. Okay, that is there. That we will discuss what is the application of this. Different kind of applications. I will show you. The applications may be one of the lectures here that I'll discuss about. Then solution of simultaneous linear equations with the help of Kksharma's rule. This is very important. That is very important for engineering students. That I'll take in detail. Okay, all the questions, because students are giving me number of questions based on Kksharma's rule. Okay, solution of simultaneous linear equations, and then all other properties we discuss about. Okay, all the Diagrams, I'll take the diagram, research diagram or search diagram that I'll take by the help of search diagram how to solve matrices of or determinants of order 3. Okay, that is it. Okay, then see you in the next lecture series.